Yo guys, welcome back to another differentiation question. So in this one we'll be looking at how to find the maximum value of this shape's area. And what we have here is a shape that consists of a rectangular base with a semicircle top attached on the upper side. So we also know that the perimeter of the shape is 50 centimeters, and we have a radius of the semicircle which is r. Now, the question I know was on everybody's mind is how the hell do we approach the shape? Well, the easiest thing to do, firstly, is to formulate some equations, okay? We already got perimeter which equals 50, and we want to find the area, so straight up we need to find the perimeter and area of the shape. So, without further ado, let's go. So, first things first, looking at the shape head on, so to calculate the perimeter, we should try and observe a few things. So we got r here, radius r, and we know we have a semicircle top. We know straight away that the circumference of a circle itself is always 2 pi r. So this is the circumference of a circle. Given that this is half a circle, then this is half the size. So this will just be pi r. Okay. We also know that these two lengths are equal in length, but we don't know how long they are. So it's best to just give it a name of x. So we got solve for x plus x, which is 2x. We also know that this length is of course double the radius. In other words, this is the diameter. So this will be plus 2r. So r plus r. Now, we also know that the perimeter itself is 50. So we can just rewrite this equation as 50 equals pi r plus 2x plus 2r. Cool. Now, how about the area itself? Well, the area is actually the easier part. So we can just divide this into two shapes. So first things first we find the area of this shape here, which is just simply, so I can label this 2r. It's just simply base times r, so x times 2r, which is 2rx, plus, and now the area of the semicircle. So the area of a circle on the side is always pi r squared. If it's a semicircle, which is half this, so it's going to be plus pi r squared over 2. Not bad, is it? Now the question is, we should always keep this, the question itself wants us to keep this in terms of r, okay, so we should solve this in terms of r. So the question is to make a formula and to make x a subject in the first equation and substitute back into the second equation. So let's do this. So using the first equation, so I'll call this equation 1 and equation 2. So what do we do here? Well, let's try and rearrange this properly. So what we could do is subtract 2 pi r, so we're going to have 50 take away pi r, take away 2r, and we can divide this all over 2 and make x a subject. Simple. And if you want to make this look even neater, halving everything will give us 25 minus pi r over 2 minus r. Simple. So this will be our value of x. Now we can substitute this entire value of x into the second equation. So guys, hope you're pumped. Let's try and pop this in. So using the second equation, our area is going to be 2r bracket 25 minus pi r over 2 minus r plus pi r squared over 2. Not gonna lie, this does look quite intense, but trust me, once you get the idea of it, it's actually dead easy. Okay, so at this stage, what we want to do now is of course simplify this equation. So here we go. So let's try and expand it. So we're going to get the area equals 2r times 25, which is 50r. Multiplying that's 2r times pi over 2 will give us, so multiplying r to get r squared. 2's cancel out, so we're going to get minus pi r squared. Again, 2r times this is minus 2r squared. And then of course writing the rest of the things out. Yeah. And now what we do is collect terms. So collecting these two terms because it's the same, so this is just half the value of that. So we've got, finally the area is going to be, and of course I like to start with positive, so 50r minus pi squared plus this will give us minus pi r squared over 2 minus 2r squared. And that's it guys, this is how you calculate the area. So that's actually the first part done. So we calculate the first part. Now the easy part is to simply find the maximum value of the shape's area. All you gotta do here really at this step is to simply differentiate twice. Differentiate the first time, find the value r, pop into the second equation, see if the second root is negative, then voila, use that value of r. and then you substitute into the area itself. So let's do it. So find, first things first, so differentiating a with respect to r. This one becomes 50 minus, drop the power 2 down so we can get pi, and cancel the bottom 2, so pi r. Drop the 2 down and get minus 4r. Now, making this, send this to 0 and solving for r, what do we have? So we can factorize r here, so we've got 50 minus r pi plus 4 equals 0. Plusing this across and dividing by pi plus 4, you should get 50 over pi plus 4. 4, not r. Yeah, so that's it. Now we use this equation, so I can put on the side here to save it. So r equals 50 over pi plus 4. So yeah, I'm not gonna, this is a bit limited space, but I think it's very nice to have everything in a single place. So let's take the second derivative now of this equation, yeah? So remember, when we take the second derivative, it always should be in the same format. So let's find d2a over dr squared. What do we get here? Okay, so come on team, we got this. So differentiating 50 becomes 0. Differentiating minus pi r becomes minus pi. So remember, pi is just a number. Differentiating this will give us minus 4. So as you see, I mean, you don't even need to worry about the value of r here, because once you differentiate, the r's are gone anyway, and we know straight off the bat that this value is negative. Hence, our value of r, which is this, is a maximum. And yeah, all we do now to find the maximum, again, to find the maximum value of the shape's area is to substitute this value into the area equation itself. So this statement just proves that this is a maximum. It doesn't really mean anything. It's just a proof. Okay, so finally, I mean, I'm not going to solve it completely, but all you're going to really do is pop it in. So the area max, I'd call it, just to make it, to give it a name, be 50 over times 50 over pi plus r minus pi 50 over pi plus 4 squared over 2 minus 2 50 over pi plus 4 squared. And you know what the hell, putting this in a calculator, you should get 175 centimeters squared. And that's it, guys. Hope this helps, and I shall catch you guys all in the next video. Anyway guys, ciao ciao, and see you all soon. Bye bye.